Greetings and salutations. This is AP Calculus Homework Solutions for Section 2.2b. We're on page 112. We're going to work these 6 problems. I hope you can see the green pen okay. If not, I'll redo it. All right, number 72. We're using this position function, negative 16t squared plus v naught t plus s naught. Says a ball is thrown straight down, so this time we do have an initial velocity, from the top of a 220-foot building with an initial velocity of negative 22 feet per second. What is its velocity after 3 seconds, and what is its velocity after falling 108 feet? Well, after 3 seconds, that's going to be pretty easy, but after falling 108 feet, we're going to have to think that one through a little bit. So part A, so we know that this is s of t. So for our specific situation, we have negative 16t squared. The initial velocity is 22, so minus 22t. And then in the problem it says it's a 220-foot building, so plus 220. That is our position function. So 220, negative 22. So our velocity function would be the derivative of the position function. So that's going to be negative 32t minus 22. So what's the velocity at 3 seconds? Well, we're just going to plug 3 into the velocity equation. So that's negative 96 minus 22, so that'd be negative 118 feet per second. So that's part's pretty straightforward. Now part B is, what is the velocity after falling 108 feet? Well, we start at 220. So the position after falling 108 feet is going to be, we start at 220 minus 108. That's going to be 112 feet. So that's what our position is after falling 108. So now we would have, so what it's saying is that 112 feet is equal to minus 16t squared minus 22t plus 220. All right, so we want to know what the velocity is at that point. Well, we've got to get the time, so we need to get the time. So how much time did it take to fall to 112 feet? All right, so we would have 0, we're going to rearrange this, is equal to negative 16t squared minus 22t, and then 220 minus 112 would be plus 108, right? So now we're going to have to use the quadratic formula to solve for t. Well, that's, to remind you, that's negative b plus or minus square root b squared minus 4ac all over 2a, because this is not factorable. You can try it, but not very easy. We could make our numbers a little easier if we factored out, say, a 2, but I'm not even going to bother with that. So t is equal to negative b, that'd be positive 22, right? So this is A, this is b, this is c, negative b, plus or minus the square root of negative 22 squared minus 4 times negative 16 times 108, 4ac, all over 2 times negative 16. Well, if you go through and you don't mess that up in the old calculator, you're going to get two answers. You're going to get 2 and negative 3.37. Which one of those is extraneous? Well, you can't have negative times, so negative 3.37 is extraneous. So the answer is 2 seconds. It took 2 seconds to fall to that point. So what's the velocity? That would just be v of 2. We have the velocity equation right here. It's negative 32 times 2 minus 22. So we're going right back up here to this, and that's negative 86 feet per second. All right, so we had to do a little quadratic formula business there, so you might not have done that for quite a while. All right, in my pre-cal class, we did it. Algebra 2, we did it. Okay, so number 73. This time, the position function we're using is negative 4.9 t squared. So we're using the metric system here, plus v naught t plus s naught. So you might remember from physics class that the acceleration due to gravity is 9.8 meters per second squared. So we're in meters now. If you 2 times negative 4.9 would give you negative 9.8. So it says a projectile is shot upward from the surface of the Earth with an initial velocity of 120 meters per second. What is its velocity after 5 seconds, after 10 seconds? Okay, so part A, we need to get the velocity function. That's going to be the derivative of the position function. So that's negative 9.8 t. Now what is do we have an initial velocity? It's 120. So S of t is negative 4.9 t squared plus 120 t. And it is shot from the surface of the Earth. So our initial position is 0, right? So this is 120. So taking the derivative, the velocity function would be plus 120. So v of 5 seconds, we're just going to plug in 5. Negative 9.8 times 5. And that is 70, plus 120. And that is 71 meters a second. Part B, we're going to find v of 10, right? 10 seconds. It's negative 9.8 times 10 plus 120. And that is 22 meters per second. All right, so it's slowing down till it gets to 0, and then the velocities will go negative, wouldn't they? Okay, 74 says to estimate the height of a building. A stone is dropped from the top of the building into a pool of water at ground level. How high is the building if the splash is seen 6.8 seconds after the stone is dropped? Okay, again, we've got negative 4. Let's see. S of t is equal to negative 4.9 t squared plus the initial velocity times time plus the initial position. Okay, so this is 0, right? Because it's just dropped. It's not thrown down. And the position at the ground is equal to what? It's equal to 0. So we just want to know, we would have negative 4.9 t squared plus our initial position. The initial position is the height of the building. So that's equal to 0. So our height, s of 0, is going to be, if we move the negative 4.9 t squared to the other side, just positive 4.9 times t squared. We know that time is 6.8 seconds, so they did the hard work for us. Don't forget to square it. All right, and that is going to be negative 226.58 meters. All right, so not too bad at all. Number 81 says the area of a square with sides of length s is given by a equals s squared. Find the rate of change with respect to s when s is 4 meters. So I gave you the hint. We have a is equal to s squared. So take a derivative to get the rate of change. That's a prime. That's going to be 2s. So at 4 meters, we'd have 2 times 4. I'm going to plug that 4 right in there. 2 times 4, which is 8 meters. Find the rate of change with respect to s. So that's 8 meters squared, I guess. All right. Then 82. Similar problem. This time we're talking about volume. We have volume equals s cubed. So the derivative of s cubed would be 3s squared. So the rate of change when s is 4 again. So 4 centimeters. So that'd be 3 times 4 squared. So that'd be 48 centimeters cubed. Okay. And last one. We have number 83. So that one says the annual inventory cost C for a certain manufacturer is, and we have this, where Q is the order size when the inventory is replenished. Find the change in annual cost when Q is increased from 350 to 351 and compare this with the instantaneous rate at 350. So to get the instantaneous rate, we're going to have to take a derivative. So we've got C is equal to 1008,000 over Q, where Q is the order size, C is the cost, plus 6.3 times Q. So part A was find the change in annual cost. So first of all, we want to find C of 350. So that's 1008,000 for you. Those of you who are annoyed when I say O. 6.3 times 350. All right, so that is $5,085. And then C of 351, we're just going to put a 351 instead of a 350. And that is 5,083.1. So the difference in cost is $1.90. So you save $1.90 when your order size goes up by 1. All right, part B, what's the instantaneous rate of change? So we've got to find the derivative. So let's rewrite this in an advantageous way. So that would be q to the minus 1. So I'm just bringing that q up top and taking it to the negative 1 power. So c prime of q would be negative 1, 0, 0, 8, 0, 0, 0. So bring that negative 1 out front, times q to the minus 2 plus 6.3. Derivative of 6.3q is just 6.3. So c prime of q is negative 1, 0, 0, 8, 0, 0, 0 over q squared plus 6.3. So let's plug in a 350 there. That's negative 1, 0, 0, 8, 0, 0, 0 over 350 squared plus 6.3. All right, if your calculator doesn't fail you, that is negative $1.93. This is actually going to be negative, so you would do 351 minus 350 there. So it's negative 190. The instantaneous rate at 350 would be, because you're saving $1.90, the change is negative 1.93 because the curve there is going down, so the slope is negative. As the size of your order goes up, cost versus order size, as the size of the order gets bigger, the cost gets smaller. So that's why it's negative. Okay, that'll do it for this solutions video. I'll talk to you next time.